This video is introducing the concept of energy in chemical reactions. Eventually we'll get to the point of being able to work out for a reaction if it gets hot or if it gets cold, and to explain why. This is to introduce these two words, endothermic, exothermic. A process can be either endothermic or exothermic, and they simply mean whether heat energy enters or exits. And the clue comes from the name. If it's endothermic, then heat energy enters. If a process is exothermic, then that's because heat energy exits. That's what those two words mean. There are two processes that happen in every single reaction. This is an example of a reaction. We've got hydrogen molecules reacting with oxygen molecules to make water molecules. The two things that have got to happen are, first of all, these old bonds have got to be broken. And then second of all, these new bonds between the hydrogen and oxygen atoms have got to be made. Those are the two things that happen in all chemical reactions, because all chemical reactions are just atoms rearranging with each other. This is just a bamboo skewer because I'm in the kitchen, and if I'm going to break it, I've got to put energy in, and eventually I can break it. So breaking bonds is endothermic because you've got to put energy in to break things. So breaking bonds is endothermic. Slightly harder to demonstrate, but I can show you this. For exothermic, the opposite is true for making bonds. So if I bring these two things together, I've just got some spice jars. You heard that, it gave out energy, it gave out sound energy. In a similar way, if you bring atoms together to make bonds between them, it gives out energy. So making bonds is exothermic. So those are the two processes that happen in every single chemical reaction. And a reaction will overall be either endothermic or exothermic, and it depends on the balance between the energy it takes to break the bonds and the energy that's given out when you make new bonds. So I'll give you two examples. For reaction 1, let's say this is a reaction where to break the bonds we've got to put a lot of energy in. But when we make the new bonds, it only gives a little bit of energy out. Quite clearly, overall, this is going to be an endothermic reaction, because overall energy is being put in. On the other side, if we had a different reaction, and this time to break the bonds at the start, we didn't actually need to put that much energy in because they're quite weak bonds already. But when we make the new bonds, they're really strong bonds and it gives out loads of energy. Overall, clearly, this is going to be an exothermic reaction because overall energy is being given out, so reaction is exothermic. So it's all down to how easy it is to break those bonds and how much energy is given out when we make the new bonds. Last thing then, how could we tell if we were just looking at a reaction in the lab whether a reaction is exothermic or endothermic? The answer is, if heat energy exits, it will feel hot. That's because at the start, some of the energy is wrapped up in the actual bonds and we can't feel it, but at the end that energy is being given out, so you can feel that as heat energy. If you felt the beaker that reaction was happening in, energy would be being given out into your hands, so it would feel hot. Endothermic reactions are slightly less common, probably in our experience, but it's the opposite. So at the start, that energy's as heat energy, and then that energy overall gets taken into the bonds where we can no longer feel that. And if you imagine feeling the beaker where there's an endothermic reaction happening, energy is being sucked out of your hand going into the bonds of what we're making. So that is going to feel cold. There's more examples you could probably think of for exothermic reactions. Classic one is burning things. That gives out heat energy and it feels hot. There are also some examples of endothermic reactions. So if you get those packs for sporting injuries that feel cold, that's because you're making an endothermic reaction happening in it, and it draws energy in, so it feels cold.